Welcome to The Explainer. Today we're going to peel back the walls on the buildings we use every single day to uncover the hidden rules, the kind of invisible guardians that keep us all safe and sound. I mean, really, think about it for a second. We trust these incredibly complex structures with our lives every single day. But what is that trust actually based on? It's a pretty fundamental question about the world we've built all around us. Well, the answer is that the safety we so often take for granted is absolutely no accident. Nope, it's all meticulously planned and enforced through this incredibly detailed, really powerful set of rules, known simply as the Building Regulations. Now, the regulations themselves are the what? The high-level rules. But to really understand the how, you've got to get to know the approved documents. The best way to think of them is like the official recipe books for construction. Each one breaks down a different part of the regulations, giving architects and builders the practical, hands-on guidance they need to get it right. So here's how we're going to break it all down today. We'll start with how the regulations keep buildings standing in the first place. Then we'll look at how they fight fire, how they make sure our homes are healthy, how they make buildings accessible for everyone, and finally, how they're getting our buildings ready for the future. All right, first up, we're tackling the most basic, and you could say the most critical challenge of them all. Just making sure that the buildings we're in don't fall down. It's a constant, invisible battle against gravity and force. It sounds like a simple question, doesn't it? But the forces involved are absolutely immense. To manage them, builders turn to the very first part of the rulebook, Approved Document A, which is all about structural safety. So a really crucial concept inside Document A is preventing something called disproportionate collapse. The rule basically says that a single localized failure, like one column giving way, shouldn't be allowed to trigger a catastrophic chain reaction that brings the whole building down. It's all about building in extra strength and resilience. And what's fascinating is that some of these modern rules are actually based on ancient wisdom. I mean, look at this. Document A gives this super straightforward formula for how thick a simple wall needs to be. For a solid brick wall, the thickness has to be at least 1/16 of the story height. It's a perfect example of a time-tested, simple bit of engineering written right into modern law. Okay, so a building can be structurally sound. That's great. But what happens when a fire breaks out? Well, this is the next massive challenge the regulations have to tackle, stopping a small fire from becoming a total catastrophe. This is the territory of Approved Document B, and it lays out a really clever, multi-layered strategy for fire safety. It really boils down to two key things: containing the fire where it starts and getting people out fast. At the absolute heart of fire containment is this idea compartmentation. Basically, you divide a building up into a series of fireproof boxes using fire-resistant walls and floors. So if a fire starts in one box, the goal is to trap it there long enough for everyone to escape and for the fire service to arrive and do their thing. So how long does one of these fireproof boxes actually need to last? Well, Document B gets very specific, and it all depends on the risk. For a typical office building, it's 60 minutes. But for a residential block where people are sleeping, it's 90. And for a deep basement where escape is obviously way more difficult, that resistance has to last for a full 120 minutes. It is all about buying precious time. And the thinking here goes even deeper than the main structure. It's also about the surfaces on the walls. The rulebook says the building fabric should make a limited contribution to fire growth. In simple terms, that means the stuff you use for walls and ceilings can't add a bunch of fuel to a fire, especially along escape routes where every single second counts. Okay, so beyond those immediate dramatic dangers like collapse and fire, the regulations also play this huge role in protecting our long-term health. They tackle the much more subtle problems of buildings that can, actually make us sick over time. And it's not just one rule here. It's a whole suite of documents that all have to work together. You've got Document C dealing with moisture coming up from the ground, F is for ventilation, H covers drainage and waste, and J protects us from dangerous gases from things like boilers. Together, they're designed to create a safe, healthy environment inside. And these details can get incredibly specific. Take this number: 60 liters per second. According to Document F, that's the minimum power your kitchen extractor fan has to have. Why? Because it's not just there for cooking smells. It's actually a mandatory piece of safety equipment. It's designed to physically pull harmful pollutants and moisture out of the air you breathe, which helps prevent mold and just generally creates a healthier home.
Right. A building is only truly successful if everyone can use it safely and comfortably. And that brings us to accessibility and just protecting people from everyday hazards like falling or bumping into things. This is covered by approved documents K and M.
A really great example of this is something as simple as stairs. I bet you've noticed that stairs in a public building just feel different from the ones in your own home. Well, that's completely by design. The rules require public stairs to have a shallower angle and longer, deeper steps. That seemingly small change makes them way safer and more comfortable for everybody, from kids to the elderly. And this one number right here, 1,000 millimeters, shows you how the rules build in that inclusivity. That's the mandatory minimum width for a public stairway, 1 meter. It's a very specific dimension that makes sure there's enough room for people to pass each other comfortably or to help someone in a wheelchair. It's a number that literally creates space for everyone. Finally, it's so important to get that these regulations aren't just stuck in the past. They aren't only about solving yesterday's problems. They are constantly evolving to face the challenges of tomorrow. You can see this evolution so clearly in the newest rules. Document L now demands really radical energy efficiency. There's a brand new rule, Document O, that's all about tackling overheating as our climate gets warmer. And Document R makes sure that new homes are built ready for the digital age, with the pipes and wires for gigabit internet right from day one. And that focus on efficiency is pretty intense. These are the performance targets a typical new home has to hit. The key metric here is the U value, basically a measure of how much heat gets out. The lower the number, the better the insulation. And as you can see, the plan is for nearly all the heat loss to come from windows and doors because the rules for walls, floors, and roofs are now unbelievably strict. We're effectively building these super insulated boxes that waste almost no energy. So, when you look at a building, just remember, it's not only bricks and mortar. It's a complex, interconnected system of rules and requirements, all designed for one single purpose: to protect us. From the foundations all the way to the rooftop, these regulations are the unseen guardians of our safety and our well-being. And that leaves us with a final thought to take away. The rulebook is always being rewritten. So as we look to the future, as we face new challenges like climate change, new technologies, and different ways of living, what do you think the next great problem is that our buildings will have to solve?